So this section has an awful lot in it. Okay. The next section is like a free response structured section where it looks more like what your free response quiz or test would look like. And so that's Monday's lesson where we're just going to go through, and you guys you'll have time to get all your stuff checked off. If you haven't gotten anything checked off yet, you can do your recovery points, all that stuff. It can happen on Monday. Okay. I will have a little bit of time at the end of this class period, though, if any of you guys need to get, I think it's what that 2-2 end question, and some of you guys still need to get checked off. I want to fix those. But as far as putting in new zeros in for the end question today, I'm not going to do that. Okay. We'll get everything for the end question checked off on Monday. Okay. So this section, it has a lot in there. It's got everything that's related to taking the first derivative. And what we're doing is we are describing a graph without graphing it. Okay. So there are different characteristics. And when we did Rolle's theorem yesterday, we talked about the derivative being equal to 0, right? And when the derivative is equal to 0, we have a horizontal tangent line. But when I don't use Rolle's theorem, I'm looking for a critical number. And I have a critical number when the derivative is equal to 0 or where f is not differentiable. Okay. So if I have my little happy face parabola, then I have my derivative equal to 0. And that is what we call a critical number. And what you notice just by looking at this graph is that there's a minimum value. So at any critical number, I will either have a relative minimum or a relative maximum. And just by looking at the graph alone, if I were to ask you something about whether or not the function was increasing or decreasing, just by looking at the graph, because I'm going from left to right and I'm going like in a negative fashion, right? This would be where f is decreasing. And right to left, this would be where f is increasing. All by looking at this little happy face parabola. Okay. And what we know is that because I'm going from decreasing to increasing, and just by the sheer look of the graph, this is a relative minimum. I could have drawn the frowny face one and gotten a relative maximum if I wanted to. Okay. But now, what ends up happening is that how do I know that f is decreasing without graphing it? That's the key. Well, I would look at, I drew this horizontal tangent line, right? So what if I drew tangent lines along the left side of the graph? All of these derivatives would be negative slope. So all the derivatives would be less than 0. So anywhere that the function is decreasing, my derivative is less than 0. And then if I drew little tangent lines here, and my derivative had positive slope, so my derivative was bigger than 0, we would say that f is increasing. So without graphing, like if I remove the graph now, I could ask you, where's the function increasing? Where's the function decreasing? Where do I have a critical number? Where do I have a relative min or a relative max? And just by what our labels are right now, you should be able to tell me without graphing it. And that's the key. So I want to do all of this without graphing. Okay? So there's a lot of words here. I will skip them and go back to another image here. And then we'll go step by step through how we would work through one of these questions. Okay, so here, if I drew tangent lines along the graph, at any value of x, my derivative would be bigger than 0. So we would say that f is increasing. If I drew tangent lines in the middle, we would say that f prime is less than 0, so f is decreasing. Because I changed from increasing to decreasing, we would say that this coordinate point is f has a relative maximum. And this is also where f prime was equal to 0. Here, where I'm going from decreasing to increasing, your f prime is still equal to 0, and f has a relative minimum value. Okay. So now I'm going to look at the first example. I'm not going to do the second one. We're only going to do the first one. And I want to know lots of things. I want to take this equation. I want to figure out where I'm increasing, where I'm decreasing, where I have a relative min, and where I have a relative max. So I want all 4 things if I possibly can. So step 1, take the derivative. So the derivative of x cubed is 3x squared. Derivative of negative 3 half x squared is? Negative 3x. Second step, I want to know what my critical numbers are, because once I can figure out where my derivative is equal to 0, then I can test points on the right and the left of those critical numbers, and I know whether or not the function is increasing or decreasing. So I set it equal to 0, so I can factor out a 3x. So I get x is equal to 0 and 1. There's no points where the derivative does not exist because there's no x in the denominator, so we don't have to worry about any additional critical numbers. And so now all we need to do is figure out where the function is increasing or decreasing. Any questions so far about critical numbers? Yes. where we're possibly a relative min or a relative max, and where your derivative is equal to 0. Any other questions? So what I want to do now is I want to test values to the right and to the left and in between 0 and 1. So I'm going to create myself a table. If you go to a tutor, or if you want to abbreviate, the answer is no. You are not allowed to abbreviate in your table. And yes, I do want the table every single time. So one more time. I want the table every single time, and I do not want you to abbreviate. If you abbreviate within your table, either on the end question or on the beginning question or on a quiz or on a test, I give you no points, because the abbreviations are not universal, meaning that if you abbreviate on the AP test, you are getting 0 credit. Okay, so everything, when I grade, everything that I'm grading is on an AP rubric. I'm just trying to show you guys what the AP rubric looks like. Okay, so you must write it out. That means we don't abbreviate test value as TV. Okay, so when I create my table, I have along my vertical lines would be like when x is equal to 0 and 1, because those are my critical numbers. So I want to pick a value that is less than 0. So I'm looking at the interval from negative infinity to 0. And it is a parentheses and not a closed bracket, because I am not increasing nor am I decreasing at a critical number, because it's equal to 0. So it cannot be positive or a negative. Okay. I'm also a parentheses between 0 and 1. And I'm also a parentheses from 1 to infinity. I am not a square bracket on any of them. Yes. Yes, critical number is when you have a horizontal tangent. So once I set up my intervals, I want to pick values within that interval. So I want to pick a value between negative infinity and 0. I like whole numbers like negative 1. It'll make me sad that I have to go from 0 to 1, because then I have to pick a fraction. And then I want to go bigger than 1, like 2. So I'm going to take my test values, I'm going to plug it into the derivative. I would plug it into the factored form, because all I care about is my derivative bigger than 0, or is my derivative less than 0? I don't care about what the exact value is. Nobody cares. I just have to be able to tell my positive or my negative. So when I plug in f prime and negative 1, I'd have 3 times negative 1 and a negative 1 minus 1. This guy is negative. This guy is also negative. 2 negatives multiplied together give me a positive. F prime of 1/2. Three times 1/2, 1/2 minus 1. I get a positive and I get a negative. So overall I get a negative. Plug in 2. So I get a positive and a positive. So that overall I get a positive. Questions so far? So when my derivative is bigger than 0, I have f is increasing. Where my derivative is less than 0, I have f is decreasing. And then again, where f is bigger than 0, I have f is increasing. So that's my conclusion part. Where my graph goes from increasing to decreasing, I have a maximum. Where my function goes from decreasing to increasing, I have a minimum value. So at x equals 0, we have a relative maximum, but I have to figure out what that y-coordinate is. A relative min and a relative max are coordinate points. So they have to be coordinate points. So when I am going to have to plug in and find f of 0, which is 0 cubed minus 3 halves times 0 squared, which is 0. And then at x is equal to 1, I have a relative minimum. So f of 1 is equal to 1 cubed minus 3 halves times 1 squared. So I get negative a half. So I went from finding my derivative equal to 0 to creating my chart to figuring out my conclusion to then figuring out my relative min and my relative max. Okay, perfect. Thank you. So I go from chart to conclusion to finding out relative mins and relative maxes to then writing out all of my answer. Okay. So then I would have, what did I want to know? I wanted to know f is increasing on the interval from negative infinity to 0, union 1 to infinity. F is decreasing on the interval from 0 to 1. F has a relative max at 0, 0, and f has a relative minimum at 1, negative 1/2. And that is your very long answer. Okay, so little recap. Again, once you pick your test values that are inside the interval, you figure out where your derivative is, if your derivative is bigger than 0 or less than 0 for those values. So, and all I care about is whether or not I'm getting positive or negatives. I could care less what the exact value is. So I want to take it, I want to plug it into the derivative. It is easier for me to plug it into this factored form, right? It's quicker for me to figure out positive and negatives without, especially because I don't need the actual number, right? Once I do that, anytime I am bigger than 0, I am increasing. And anytime I am less than 0, I am decreasing. A maximum happens when I go from increasing to decreasing. A minimum happens when I go from decreasing to increasing. Relative mins and relative maxes must be coordinate points, which is why we found the y values. Questions? Somebody asked in a different class period about this. How long am I supposed to be able to have to do a question like this? 15 minutes. But I also have to combine some ideas from 2-7. So what we do with the second derivative and what the second derivative tells us. Actually, it's 2-8, I think. What the second derivative tells us. Okay. Questions?